Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published just a few days ago on June 14, 2025. It introduces a new system that nearly doubles the answer correctness score of a baseline Retrieval-Augmented Generation system. The paper is titled DoTA-RAG, Dynamic of Thought Aggregation RAG. Alright, so the core idea here is tackling a big problem: how to get fast and accurate answers from an LLM that needs to search a massive web-scale database. This paper's system, called DoTA-RAG, uses a multi-stage pipeline to solve this. One of its key innovations is something called Dynamic Namespace Routing, which acts like a smart traffic cop for data, sending a query to a much smaller, specialized part of the database. This dramatically cuts down on search time, and as we'll see, the results are really impressive. Also, the authors shared their implementation on GitHub. If you want to try it yourself, you'll find the full DoTA-RAG pipeline there, including a quick start guide to get it running. They've also provided scripts for batch evaluation and for using models like Falcon or Claude to judge the output. Okay, so this first chart really visualizes the impact of each stage. It plots correctness versus faithfulness, essentially how right the answer is against how well it sticks to the source documents. You start with the baseline, way down in the bottom left. Then, step by step, they add each piece. First, a better embedding model, which helps find more relevant text. Then, that dynamic routing. After that, they add pruning to filter results, and a re-ranker to put the very best documents at the top. With each step, performance climbs up and to the right, with the final DoTA-RAG system achieving the highest scores for both. Building on that, this next diagram shows us the entire DoTA-RAG workflow. So a user's query first gets rewritten to be clearer. Then, in a clever parallel step, the system both routes that query to a specialized database and creates a query embedding, which is basically a numerical version of the text. This combination retrieves an initial 100 passages. Those are then pruned down to the top 10 using BM25, a keyword matching algorithm, and a more advanced cohere re-ranker. Finally, these 10 best passages are fed to the Falcon 310B model to generate the final answer. Okay, so this next table really quantifies the impact of each of those pipeline stages we just discussed. It measures correctness on a scale from -1 to 2, and faithfulness, or how well the answer sticks to the source text. You can see the baseline starts quite low. But the most dramatic change comes from adding dynamic routing. It slashes the time per question from over 100 seconds down to just 19. Then, adding the re-ranker pushes both correctness and faithfulness to their peak scores. The final system lands with a correctness score nearly double the baseline, showing a fantastic balance of speed and accuracy. So, to really understand the challenge this system is tackling, these charts break down the massive database it has to search. On the left, you see the topic breakdown, a huge variety, with finance and business being the largest category at over 9%. This topic taxonomy is what enables that smart dynamic routing we talked about, sending a query to one of 24 specific areas. Then on the right, you see the different document formats, everything from news articles to personal blogs. This incredible diversity is exactly why a simple search struggles, and why this routing is so crucial. So bringing it all together, the DoTA-RAG system presents a really elegant solution to a huge problem: how to get fast, accurate answers from a massive, messy web database. For me, the two biggest insights are, first, that using metadata to smartly route queries is a game changer for speed, cutting search time by more than half. And second, that a hybrid retrieval approach, which layers different search and ranking techniques, is key to improving factual accuracy. This work really shows a practical path forward for building fast, reliable knowledge systems. That's all for this episode of the AI Research Roundup. Thanks for tuning in.